Alrighty, welcome. So today we're going to be looking at the exponential function. And the exponential function is any function of the form y is equal to a to the x, where a is some positive number. Weird things happen when we have a negative number. You might remember from geometric sequences that when we have a negative value of r, we get that reflective behavior. Similar thing here. So we're only going to be looking at positive a. So let's just get a sense of what it actually looks like. And I think the best way to do it is give an example. So let's look at the function y equals 2 to the x and use a table of values to actually work out some values of it. So let's draw up a table of values. Alrighty, so let's start from -3, -2, -1, 0, 1, 2, and 3. Might give myself a bit more space. Alrighty, so starting in the middle of the table, we get 2 to the 0 equals 1, 2 to the 1 equals 2, 2 to the 2 equals 4, and 2 to the 3 equals 8. Going on the left-hand side, we get 2 to the -1. And in order to solve this, we're going to have to use our negative law from the index laws. So it's going to be 1 over 2 to the 1, which is just a half. And then we're going to get 2 to the -2, which is 1 over 2 squared, which is a quarter. I would guess the next one would be an eighth, but it's good to check. 2 to the -3 equals 1 over 2 to the 3 equals an eighth. Now that we've got our values, we can now draw a quick graph. So the first point, 0, 1. Then we get 1, 2. And then 2, 4. And so on the positive side, you can kind of see there's this increasing behavior, similar to what we see in like a quadratic, but quite extreme. On the left-hand side of the x-axis, we can see what we're going to get at -1, a half, at -2, a quarter, and then at -3, an eighth. And so you can see that it asymptotically approaches the x-axis. So let me just label the points. You can see these are the points that we end up finding on this line, y equals 2 to the x. And you notice it's sort of increasing on the positive side, but on the left-hand side, it's getting really close to the x-axis, but it's never actually going to reach the x-axis. Remember, we call this asymptotic behavior. Yeah? Where we'd say there's an asymptote at x equals 0, basically meaning it's approaching 0, but y equals 0, the x-axis. So there's an asymptote at y equals 0. It's approaching this line, but it's never going to quite reach it. So let's imagine then what's going to happen when we translate this line up or down. Well, as we do that, the asymptote is going to move as well. So let's have a look at translations. Alrighty, so let's have a look at the definitions of a vertical translation. Well, just as a reminder, if we have some function f of x and we write it as f of x plus some constant c, that is going to be a vertical translation. It is going to translate up by c units, basically meaning it's going to move it up c. So in our case, if we've got y is equal to a to the x, that's going to become y is equal to a to the x plus some constant c. So let's type that into Desmos and have a play with it. So you can see I've got my function right here. And in this case, I've chosen a is equal to 1. Well, notice a equals 1 is a pretty boring case, and you'll see that it basically looks like a straight line. You can have a think about why that might be, but let's change the value to, say, around 2. And you can see for 2, this is the shape we were drawing before, right? That is going to be happening along here. So you can see here, this is the sort of shape that we're getting. And watch what happens. If I make c back down to 0, then you can see it's approaching the x-axis, but if you actually zoom in, it never actually reaches it. That's that asymptote that we were talking about. If I move c up, it's going to move it up. But notice what happens. If I make c, let's say, 5, well, you can see that it looks like it's now approaching the line y equals 5. Right? Because you can see that it's approaching this blue line, but it's never actually reaching it. So C kind of controls our asymptote. So rather than writing y equals 5, let's write y equals C. And for fun, let's make it a dotted line. As I change C, you can see the asymptote is going to move along with us. Okay? So that's going to be basically our way of controlling how up or down the, where the asymptote goes. Okay? But that's only half of the control we have. The other half of the control we can have is reflections. And remember, there's two different types. We have x-axis, and for an x-axis reflection, we have f of x becoming negative f of x. So in this case, we would get y equals a to the x, then becomes y equals negative a to the x. Now notice it's not negative a to the x, it is just negative times a to the x. So if I put a minus out the front here, you can see all it does is it reflects it so that instead of increasing, now it's decreasing, it's going downwards. But notice the asymptote is still doing its exact same job. Well, that's one type of reflection. What about a reflection in the y-axis? Well, for the y-axis, we get f of x is equal to f of negative x. So the negative doesn't affect the whole function, it just affects x. So we get a to the x, and it becomes y equals, that should be an arrow as well, y equals a to the negative x. Let me get rid of this negative and add a new one up here. And you can see now, instead of having the asymptote on the left and increasing on the right, it's just reflected that. But once again, C is just moving us up and down. Okay? So C is going to control the asymptote, and then the negatives are going to change to the different signs. So let's make some notes. Essentially, I have 4 different cases. No reflection, reflected in the y-axis, reflected in the x-axis, reflected in the y-axis, and reflected in both axes. So let's have a look at what they're going to look like. Well, for some asymptote, we're just going to get an increasing shape just like that, where it's asymptotically trying to reach the C, but it's not going to reach there. Let me not move it anyway. Let's just do it up along the x-axis just to make it nice and easy to look at. Alright, so there's our first two. If we reflect it in the y-axis, it's going to look like this. And if we reflect it in both axes, that's going to look like this. So those are basically our 4 different shapes that we have. Increasing, reflected, then we have decreasing, and then decreasing and reflected. So those are basically our 4 different shapes that we're going to be dealing with. Now the plus C is just going to determine where they're approaching, what's their asymptote. So let's try to do a quick sketch. So for the moment, we're only going to be looking for the y-intercept and the asymptote. Now, we can't currently work out the x-intercept, and we'll go through that a little bit later why. But the asymptote we can just read off. So the asymptote is always just going to be whatever the constant is on the end. So in this case, it is going to be y equals 6. And the y-intercept for this function is going to be when x equals 0. So we get y is equal to negative 3 to the 0 plus 6. Now, just as a reminder, order of operations means that this happens before the minus, which means we get minus 1 plus 6, which is 5. So let's use these 2 pieces of information to do our sketch. So the asymptote is at y is equal to 6. Let's draw a line. And then we've got an x-intercept at 5. Y-intercept at 5. Alrighty, now this is where we need to have a look at the function again. We can see that there's a negative outside of the function, Well, that matches with this type here, where we've got that. So it should be a reflected case, reflected in the x-axis in particular, meaning that instead of going like that, which would be our standard shape, it's going to be going out like this. And that is our shape. So y is equal to minus 3 to the x plus 6. Now just for completeness, let's do our domain and range. Now hopefully you've noticed that for the domain, there's no issues. There's no values you can't sub in, so double R will be fine. But the range, you'll notice, is totally based on this asymptote. So it does have two limits. And in this case, here it's pointing down to negative infinity. So the smallest number we could have is negative infinity. But here you notice that it's never pointing towards infinity. It's actually always getting trapped. This y equals 6 is like an upper barrier. But because it's an asymptote, you never actually reach it. You get very, very close to 6, but you never reach it. You can always, there's always a tiny bit of space. And so that would be the domain and the range for this function, because if you have a look at the y, it's almost there, but not quite. It nearly reaches the asymptote, but not quite. Alrighty, so that's how we can sketch these functions. I'll see you in the next one. Goodbye.